Right. So it says, which of the following is an antiderivative of the square root of 1 plus x cubed? Yeah, I know. My kid is so funny. She messaged me. She goes, "Are we do anything after school on Friday?" I was like, "No, why? You got a high date?" She goes, "Nope, need to do officer interviews." I'm like, okay. What do you think? Antiderivative. To get all my favorite colors out. You're attached to it? Well, you can't give it away until after your AP test on Monday, so. You'll have to come back and give it back, yeah, because you got to have it for your test. Okay. Don't forget your textbook, though. That I will let you give away. I need to send a reminder, don't I? Yeah. So maybe we'll all bring them in on Thursday. Be done with those. But anyway. All right, so this one's a little weird. So remember, an antiderivative, you're thinking doing the integral of the square root of 1 plus x cubed dx. This one would be hard because it's obviously a composition. And what would be the derivative of the inside stuff? 3x squared, which we don't have anywhere in that problem, nor can we create it, okay? So that's when we move into the fundamental theorem, all right? And that's what's kind of interesting about this problem is because we really don't have a way to evaluate this antiderivative unless we use the fundamental theorem. And so it would actually be E because we do the integral from 0 to x, square root of 1 plus t cubed dt. So if we're doing fundamental theorem, we could just plug it in there. So the antiderivative would be that integral. So that one's a little bit tricky. All right, so that's fundamental theorem. That will pop up periodically. All right, if they don't ask you to evaluate it, sometimes they'll ask you just to, apply it in some way. It's fundamental theorem. This one was a lengthy quote, but it's a good one from the goat himself. One more of those. I'm a little bit sad. Okay.
This week we'll never go to again.
Sinking in, huh? It's okay. Like, I was trying to think, was I emotional at like graduation? I was not until we got ready to leave and the girl in front of me started crying. And then I cried, I think just out of sympathy. So, but it was good. It's a good cry though. Like if you do cry, if you don't cry, it's okay too. Like it's a fun transition in life. Okay, today we're going to talk about the first response questions that we love to hate. Right? Because I thought it was interesting that Trevor Pack, he's the head guy of College Board, put out a thing yesterday that don't just immediately say my teacher didn't teach me this when you see a question, because certain questions are written to ask you to apply something that you've learned. So you'll always encounter at least one, if not multiple questions that you're like, what? Okay, my favorite's when they happen on the free response and there are memes that exist afterwards. So anyway, these are, according to College Board and ChatGPT, my good friend, the most common challenging topics that we see on the free response questions. And you may feel like you're good at them. I would say this is the biggest one, is your justification of reasoning. All right. Saying the right words in the right way to get the points. You may know how to do the math, but we can't get the statement out there enough. Fundamental theorem, which is what we just did. But you guys are pretty good with those questions. And I feel like you're good with differential equations and slope fields. It's just me. And then, of course, anything contextual can give you a headache every now and then, right? Because they're going to use weird things as your context, right? And then how do you get better with those things? Obviously, practice release free response questions. The great news is for everything that's been released, and a lot has been released, there are videos of people working it on YouTube. All right, so if you get into a question, you're like, I do not get this. If you're just looking at the scoring guide, it's nice that you can go in and watch somebody else solve it. And my favorite thing is, we have to wait 3 days after the test before the questions are released where we can see them. And there's always somebody at midnight who works them out and puts them on the internet somewhere, right? So you can see them. And I love that. And then just focus on clear justifications. I think that sheet that I gave you day one where it talks about how we prove something is a really useful resource for you. Strengthen your conceptual understanding, review the things that are still giving you trouble, and seek feedback, all right? Worked out videos and explanations on that. So what I want to do, and don't panic because there's 17 things here. I've put one free response question on everything. We may or may not do them all. We'll just see what happens, okay? But I want to pick out the ones that are most well known in terms of making people go say, what? But I think we'll start to see patterns in those as we work through them. Okay, so I want to start with, I remember when my kids got this question in 2021. It was the spinning top problem. All right, that's what it was referred to, and the memes were fun, okay, when they came out. So they give us this region. So this is a non-calculator question. Company designed spinning toys using the family of functions y equals cx square root of 4 minus x squared, where c is a positive constant. The figure shows the region in the first quadrant bounded by the x-axis and the graph. Each spinning toy is the shape of the solid generated when such a region is revolved about the x-axis. Okay, so we're going to revolve around the x-axis, which is important. Both x and y are measured in inches. Okay, I don't know if I'll need that, but I'm going to keep it. All right, so that's what they've told me. And then this curve that I have, y equals c times x square root 4 minus x squared. C is just a number. It's a constant. All right, so it's a, well, thanks for that update. All right. So for the first part, it wants us to find the area in the first quadrant bounded by the x-axis in this graph for c equal to 6. So this one, they tell me what c is. And most of my kids did really good with this part. All right. But let's talk about how we do area. All right. Of that region. What would I do just to do the area of that region? I just do an integral. Okay. Now, the thing we have to know is where this bad boy is going to hit the x-axis. Right? So how would we figure that out? Because we've got to know our boundaries. Yeah, find where it equals 0. Okay, so we would take the function. We know we're replacing c with 6. So where does 6x square root of 4 minus x squared equal 0? All right, well, it's factored, which is good news. All right, so we know that 6x would equal 0 and 4 minus x squared to the 1/2 would equal 0. All right, so let's find those boundaries. X would be 0. This one, I would square both sides, so 4 minus x squared would equal 0. X squared would equal 4, or x would equal plus or minus 2, right? It wants me to do the first quadrant, so what am I going to use for my boundaries? 0 to 2, okay? And I've got 6x square root 4 minus x squared dx. Right? So again, non-calculator, this is the integral that we want to do. There's several ways that you could do this one. okay? It is a composition, all right? But I don't know that that 6 is the constant that I need, so I'm going to pull it out. So 0 to x times the square root. Actually, I'm going to write that as 4 minus x squared to the 1/2. Okay. What would be the derivative of that inside stuff? -2. So if I put a -2 inside, I need to divide by a -2 outside. Okay. So when we do that, I'd keep the -3, and let's think about our antiderivative, okay? It's just going to be the antiderivative of this thing to the 1/2, all right? And so when we do an antiderivative, what do we do to the exponent? We add 1, so that's going to give me 4 minus x squared to the 3/2, and then what would my constant be? We would divide by 3/2, so we'd pull a 2/3 out there, okay? And we're going to evaluate from 0 to 2. So that would give me the -3's would cancel, and so I would get -2, 4 minus x squared to the 3/2, and we're going to evaluate from 2 to 0. And so let's evaluate. So it's going to give me -2 times 4 minus 4 to the 3/2 minus -2 times 4 minus 0 to the 3/2. Okay. Well, 4 minus 4 would be 0. -2 times that'd be 0. Okay. It's going to be plus 2, 4 to the 3/2. So that would be the square root of 4 cubed. So 2 times 8, which would be 16. Now, we can put units on this one because they gave me measurements for the x and the y. Okay, if we're doing area, we're talking about inches, but they would be square inches. Okay. So right off the bat, this is not an easy antiderivative to do. All right, it's got some complicated arithmetic in it. You had to do all these zeros over here. This part was worth 3 points. All right, you got 1 point for the integrand. All right, so the inside stuff here. You got 1 point for the antiderivative, and then you got 1 point for the answer. So it was worth 3 points. Right. And I think my kids got at least 1 point. Most of them did on this one. All right. All right, so then we move to B, okay? So it's known that for this function, the derivative is equal to, and they give me all that, for a particular spinning toy. The radius of the largest cross-sectional circle slice is 1.2 inches. Okay, what is the value of C for the spinning toy? All right, so this one's a little bit more complicated, and I think this was where everybody was like, what? Okay, what makes this one interesting is we're talking about the largest cross-sectional circle, all right? In other words, we're talking about the max, okay? So that was just a weird way to say that. All right, they're talking about the maximum. And what do we have to do to find maximums? Where do they occur? And then what's that point in the middle called? Between where it goes from increasing to decreasing. So zeros are our critical points, okay? So we're looking for where dy dx is equal to 0. And that's what freaked everybody out on that question. All right, because of how it was listed, okay, we were looking for where the max would occur. Well, it has to occur at a critical point, right? So we're going to take that derivative, which they gave me, and I'm really grateful for, c times 4 minus 2x, or c, 4, whatever, over square root of 4 minus x squared, and we're going to set it equal to 0, okay? What's the only part we have to consider in order to figure out where it's equal to 0? The top part, okay? We only have to figure out the top part. So we're going to take c times 4 minus 2x squared, and we're going to set it equal to 0, and we're going to solve for c. Okay, we're going to solve for c. Now, what makes this interesting is because it's already in factored form, okay, you could say c was 0, but is that going to give me anything if c is 0? No. Okay, so we're going to take just that 4 minus 2x squared and set it equal to 0. So I'm going to get negative 2x squared equals negative 4, or x squared equals 2. So x would be square root of 2. I don't have to consider the negative because it told me in the beginning that c was always what? Positive. Okay, so that is the value of the the x. Yep, that letter. What was it? It was x. Okay. Now, we have to figure out in the original function, all right, what c would be. Okay, what c would be when x is the square root of 2. So we're going to go back up here to the original function, which was cx square root of 4 minus x squared. We're going to find that y value, all right, because they told me the max was. I know that maximum value. Okay, so y equals cx square root 4 minus x squared. And I'm going to plug in x equal to the square root of 2. So I get y equals c times the square root of 2 times the square root of 4 minus the square root of 2 squared. Okay. So y is going to equal c times the square root of 2 times the square root of 2, correct? And so that would give me 2c. So we know the y coordinate is 2c, all right? Well, they told me the max value was 1.2. So 1.2 was equal to 2c. And so then c is going to be equal to 1.2 divided by 2, which would be 0.6. Now, that was worth only 2 points, which I found kind of hateful, all right, because it was a lot of work to get those 2 points, right? You got a point for setting the derivative equal to 0, and that's where my kids goofed up, like, because they never even did that part. They just wrote down random crap, okay, and that's okay. Write something down. You never know what you'll get a point for. Just don't put IDK or Mary Had a Little Lamb, something stupid, all right? Try to do some math in there, you might get a point. But that was the part that freaked people out, all right? Even though it was just saying the largest, so it was a maximum, you know, in the heat of the moment, it was easy to forget that. So that's where they landed, okay? All right, then the last piece of this problem says, for another spinning toy, the volume is 2 pi cubic inches. What's the value of c for this toy? Okay, so let's just think for a second how we would do volume. All right, we know we're going to rotate it around the x-axis. So we're going to have that vertical, all right, representation. When I rotate it, it makes a cylinder, right? And so volume would be pi r squared times our height. Well, we've always said that our height is like that dx that we use because we're doing infinite cylinders in there, okay? So we're going to come down here, and we're going to put all that volume stuff together, all right? So we know that volume is equal to pi times the integral, we know it's 0 to 2, of cx square root of 4 minus x squared, the whole thing squared. All right, dx. All right. Now, you do get a point for just writing it down, all right, for the integrand, and you get a point for the boundaries. All right, so even if you couldn't integrate it after that, you at least got points for that. Okay, now, this is where it's going to get interesting. Right? I'm going to actually multiply some of this integrand out, all right? That's going to give me a c and an x, and then c and an x squared. And then if I square that 4 minus a square root of 4 minus x squared, I get 4 minus x squared and a dx. Okay, so I did that on purpose. All right, did that on purpose. Oh, and the c is squared too. Sorry, you square everything. Okay. Now, that c is a constant, so I'm going to pull it out. So I have pi times c squared integral from 0 to 2. And I'm going to distribute the x squared because I think it's going to make it easier for me to integrate. All right, so I'd have 4x squared minus x to the 4th dx. All right, so pi times c squared. Antiderivative of 4x squared would be 4/3 x cubed minus 1/5 x to the 5th. And we're going to evaluate that from 0 to 2. So pi times c squared, right? If I plug 2 in, that'd be 4/3 times 8 minus 1/5 times 32. 2 times 2 is 4, 2 is 8, 2 is 6, 2 is 32. Yeah, okay. Luckily, if I plug in the 0, he gone. Right. All right, and let's just keep simplifying that. So that gives me pi times c squared. That's going to give me 32/3 minus 32/5. We're going to need a common denominator. So pi times c squared. 32 times 5 would be 160/15 minus times 3, 96/15. So I get the volume pi times c squared, 65/15. 64/15. Okay. Lord have mercy. Okay. And you'd hope we were done at that point. Okay. You did get a point for the antiderivative. So you got basically 3 for just the setup, even if you didn't get all the arithmetic done at the end. Okay. They told me the volume was 2 pi. So what we're going to do is take this expression we just got. We know the volume is 2 pi. And we're going to set it equal to pi times c squared times 64/15. Well, what's going to happen to the pi's for sure if I start solving? Yeah, they're going to cancel out, right? And then that's going to give me, if I multiply by 15/64, that's going to give me 30/64 equals c squared. Or c equals the square root of 30/64. And you could leave it just like that. You would not have to simplify it. Okay, again, you see why this one was a tough problem and people didn't like it? Felt a little bit excessive, I'm not going to lie. Okay? Because it asks you to do all this stuff. It asks you to do area. It asks you to do all this different antiderivative. It asks you about maximums. And it asks you to do volume. So it felt like a lot for 9 points. Sometimes it feels like the 9 points aren't quite so terrible, but that one was pretty rough in my opinion. And the thing I would tell you is if you encounter one like that and you don't know where to start, go to the next one, come back. All right? Because hopefully the next one would not be quite so terrible. All right? That's always my advice. Okay. You ready? Okay, so let's look at this one. This was the famous potato problem. Okay, again, the memes were exquisite. All right, the memes were exquisite. It was from 2017, and I'll never forget, my kids came running back in here because that year they took it in the sports center. And so they came running back across the campus when they got done, and they're like, Miss Moore, there was this whole problem about this potato, and blah, 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 and they just kept going on and on. I said, y'all are not supposed to be talking to me. You know, and they're like, yeah, but it was terrible. I was like, okay, it's allowed to be terrible. Let's see what it says. All right, so here we go. So at time 0, a boiled potato is taken from a pot on the stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius at time 0. I'm going to think that that initial condition is important, so I'm going to write it down. Okay. The internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0. Now, that's probably important too. Okay, but that's the internal temperature. Says the internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation. So they gave me a differential equation, dH dt, where h of t is measured in degrees Celsius and h at 0 is 91. Write an equation of the line tangent to the graph of h at t equals 0, and then use this equation to approximate the temperature at t equals 3. Okay, so what is part A, just in the easiest sense, asking me to do? All right, we need to write an equation of a line, okay? We're going to write an equation of a line, so we need the slope. So I need dH dt at t equals 0. So we're going to plug that in. So negative 1/4 times 0 minus 27. That would give me a positive 27/4. So that's my slope. It also gave me the point 0.91, okay? So we're going to write that tangent equation. So y is going to equal 27/4, okay, x minus 0, and then plus 91. Okay, so that's the first part. Then it says use that equation to approximate the temperature at t equals 3. So we're going to do y evaluated at 3. All right, 27/4 times 3 minus 0 plus 91, all right? Once we plug that in, we can stop, all right? Now, I'm not keen on that just because I like a numerical, answer, but you can leave it that way, okay? It works out to be, gosh, I don't know, 27 times 3 would be what, 71/4? Plus, and then 91/4 would be 364. And if I add all that together, 435/4, something like that. All right, did I do that right? No, I did not. Okay, time out. Chirp. It's h minus 27 right there. I put in the wrong thing. So that would be 91 minus 27. That makes a difference. So that gives me negative 1/4 times 8, 64. Oh, that's much better. Equals negative 16. Oh, yeah, that's a much better slope. Okay. So now if we write our equation, y is going to equal negative 16 x minus 0 plus 91, or negative 16x plus 91. And if we evaluate y at 3, negative 16 times 3 plus 91, or negative 48 plus 91, that would be a 3... 43 degrees? Yeah. Okay. Yeah, I like that better. The good news is it was worth 3 points. One for the slope, one for the tangent line itself, and one for the approximation. Okay, seems unfair in comparison to that last one we just did. Okay, but that one was worth 3 points. All right, in part B, use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time equals 3. Why is the second derivative necessary to do that?
You can't tell if it's increasing or decreasing based off of just dH dt.
That's right. We got to have the concavity. All right. If it's for overestimates and underestimates, we're looking at the concavity. So if it's concave down, We have an overestimate because our tangent would be above it. If it's concave up, it would be an underestimate. Okay, so it all depends on that second derivative. So for part B, we're going to find that second derivative. All right, so if dH dt is equal to negative 1/4 h minus 27, okay? You could go ahead if you wanted and distribute that. So negative 1/4 h plus 27 over 4. So when you did your derivative, you'd have fewer things to look at. Okay. And so if we do that, if we do our second derivative, okay, the derivative of negative 1/4 h is just going to be negative 1/4, and then we've got a dH dt because it's implicit. Derivative of 27 over 4 would be 0, right? So now we're going to plug back in that dH dt, which you'd already done. And so our second derivative would equal 1/16 h minus 27, okay? And then we're going to plug in, evaluate that second derivative at h, or at t equals 3, correct? Yep. Okay. So the thing about this is where we get to this part, and this is where it got tough, is you had to go back and look, okay, in this original stem. And this is where it said for that the internal temperature is always greater than 27 degrees for time greater than 0. Okay? So if the internal temperature H is always greater than 27 at time equal 0, time greater than 0, so at t equal to 3, d squared h dt would have to be positive because h would be bigger than 27. Does that make sense? So it'd have to be positive. So that means that it is concave up. And because it's concave up, we have what kind of an estimate? An underestimate. Okay? So because d squared h dt squared is greater than 0, right? H is concave up. At t equals 3. Therefore, our approximation is an underestimate. Okay, now, this seems unfair. It was only worth 1 point. The correct answer with a reason. I just don't understand how they throw points around. I think that's why I need to be a reader sometime. Anytime it's with respect to time. Yeah. Because H was the value that we had in the problem, not the T. So that makes it implicit like the Y. All right, then we got to the last part. And it says for t less than 0 and t less than 10, an alternate model for the internal temperature of the potato is given by this differential equation, where g of t is measured in degrees Celsius, g at 0 is 91. Based on this model, what is the internal temperature of the potato at time equals 3? Okay, so here we go. So on C, it tells me that dg dt is equal to, go back up here, negative g minus 27 to the 2/3. Okay. And so with this one, we want to find the internal temperature, all right? We want to find g of t, okay? This is a differential equation. To solve it, we're going to have to separate our variables. Okay, so I'm going to get dg over g minus 27 to the 2/3 equals a negative dt. All right, we've got to solve for g. We've got to figure out what is our function because we need to use it to make an approximation. I'm going to rewrite that as g minus 27 to the negative 2/3 dg equals a negative dt. So we're going to separate the variables. You get 1 point for doing that. Okay, so we separated the variables. Once we separate the variables, we're ready to integrate. Okay. Now, it is a composition on this left-hand side, but what's the derivative of g? Just 1, so we're good. We don't have to fix it, okay? So we're going to keep the g minus 27. We're going to add 1 to the exponent, so that's going to make it a positive 1/3, and it's going to need a coefficient of 3 in the front, okay? Is going to equal the derivative of a negative dt, would just be negative t plus my constant, okay? So you get a point for the antiderivatives. Okay. Now we need to use our initial condition. We know that g of 0 is equal to 91. Right? So we're going to plug that in to solve for c. So 3 times 91 minus 27 to the 1/3 equals the opposite of 0 plus c. Okay, 91 minus 27, 64 to the 1/3. What's the cube root of 64? 4. So c is equal to 12. So I have 3 g minus 27 to the 1/3 equals negative t plus 12. Okay, you got a point for putting a plus c and then solving for it. Okay. All right, so now let's try to solve for g in this bad boy. I'm going to start by dividing by 3. So g minus 27 to the 1/3 is going to equal negative t over 3 plus 4. You could leave that negative t plus 12 over 3, right? How do we get rid of the 1/3? Cube both sides. So I'm going to get g minus 27 equals negative t over 3 plus 4 to the 3rd. And then to get g by itself, g would equal 27 plus that. Okay, and so you got a point for the equation itself. And then the last point comes from actually finding g at 3, because that's what it asked me for. Okay, so to finish this off, we're going to take g at 3. It would be 27 plus negative 3 over 3 plus 4 to the 3rd. So 27 plus negative 1 plus 4, 3 to the 3rd. Or 27 plus 27, which would be 54 degrees Celsius. So you got a point for that. So that bottom part was worth 5 points. And most separable differential equations are at minimum worth 4. So if you get good at those, that's a guarantee to some pretty decent points, all right, while you're working. My husband is driving the DECA bus today for the field trip to Topgolf. Ms. Foster just said, FYI, threatened them all with the wrath of Jennifer Moore if they didn't act right or left Denton's bus dirty. Yeah, I'm sure they're real scared. Okay. Denton's just excited he gets to play golf for free. Yeah, she's like, we'll pay for him to play if he'll drive us. And he's like, done. Cha-ching. He loves being a bus driver. You couldn't pay me enough money to do that job. Ain't no way. I'd be scared to death. Especially after how they treated Miss Pam when, her bus flipped over, and she's precious and been driving for like 30 years.
Bro, that's my sister's bus.
Really?
But she wasn't on it.
Was she's on it? Yeah. Oh my gosh.
That like freaking bridge they had to drive over? You talking about the one in Bethany?
Yes.
That bridge, bro?
Well, and it was like what happened was they don't really drive over that bridge, but she hit that big pothole. She was in a different bus that wasn't hers because hers was in the shop. And you don't see things right. My Denton says it all the time. If I have to drive a different bus, he hates it because like there's this one bus they always put him in as a sub bus, and the seat just gradually goes down the whole time he's driving. So every time he gets somewhere, he has to pump it back up, and then it goes back down. So bless her heart. I feel sorry for her.
Did you go to jail or something?
No, she got cited with a ticket after the fact, so not during the anyway. It just seems bogus, but anyway, it is what it is. She's not gonna lose her job or anything. Okay, this one I just like because it had some interesting functions in it, and it was one of the ones listed by AP that people struggled with. It was from the 2022 test. It was number 2. So it is calculator active, which is good news. Okay, so this is a calculator question because it's number 2. Okay. So it says, let f and g be the functions defined by ln of x and x to the fourth plus 2x cubed. The graphs of f and g are shown above. They intersect at x equals -2 and x equals b. So I think it's interesting they did not tell us what the intersection was. Okay, I have a feeling, just a sneaky suspicion, I'm going to need to know that value. Okay, now, can you tell which one is f and which one is g? Okay, all right, if you weren't sure about f, we could for sure tell g because that fourth degree would have to be up, okay? So we know this bottom function is my g, and this top one would have to be that logarithm function, which is f, okay? And that's probably important. So they tell me they intersect at -2. We need to find that intersection point of b. So let's do that first. Put those equations in your calculator, and let's get the intersection. Let me get my calculators. That's what Dick got me for my birthday. My new Jordan Mason trip.
Oh, it's cute. Birthday, what's your birthday?
It was the 26th of April.
Aw, I didn't know. Wait, do you have school?
No, it was a Saturday. I gave my pre-calc practice test that day.
Oh, happy birthday.
Thanks. That's when I went and bought my prom dress, too. I love that dress. So what did you get, about 0.782? Okay. So I think we're going to need it, all right? So I just want to go ahead and do that. Remember, this is where you could store that value in B if you wanted to. So you could go back to your home screen, and you could type in X, hit the stow button, and then alpha B, and it would store that value for you, so you'd have it. Okay, you don't have to. You can go ahead and approximate it and use 0.782. All right, it will give you the same answers regardless. Okay. All right, so on A, it says find the area of the region between F and G. How would you do that? Integral. Okay, we're going to go from -2, and you can actually write B up there because you've already found it. You don't have to tell them what that value is, which is nice. And then top function, which would be f of x minus g of x dx, and you can write it just like that, and you're going to get the points for the integral. Okay, because it's calculator, we don't have to restate and write the whole thing, which is nice. Okay, so I'm going to use my math 9. right? And I'm going to go from -2 to alpha b. And then I'm going to do, since I stored them in y1 and y2, alpha trace y1 minus alpha trace y2 and a dx. Right? Those are my favorite. And it was worth 3 points. Okay? One for the integral, so the inside stuff, one for the limits. All right, so -2 to that b, and then your answer. So we'll take it. Right. So that's nice. You don't have to repeat everything. Right? And then they started to lose their mind. Okay, so they gave us one nice thing, and then they were like, yeah, just kidding. Okay, so it says for -2 to b, let h of x be the vertical distance between the graphs of f and g. Is h increasing or decreasing at x equals -0.5? Give a reason for your answer. Okay, so now let's just think for that for a second. It says h of x is the vertical distance between the two functions. Okay, so vertical distance, that would just be what? Top minus bottom. So we would do h of x is equal to f of x minus g of x. That's what that vertical distance, that's what that function is. Okay? And it wants to know, is h increasing or decreasing at x equals -0.5? What tells me if something is increasing or decreasing? The derivative is positive or negative, okay? So increasing, decreasing, all right, h prime would be greater than 0. Decreasing h prime would be less than 0, okay? So I need h prime. Okay, I need h prime. I need h prime at 1.5. Well, the good news is, okay, h prime at 1.5 would just be f prime at 1.5 minus g prime at 1.5, or the derivative of that difference. Okay, so we can do that on the calculator. All right. Math 8, we'll take the derivative with respect to x, y1 minus y2. And our x value would be 1.5. Okay, and I get -26.778. Okay, so now let's justify. All right. Anytime it says give a reason, that means they want an explanation. Is it, oh, -0.5. Sorry, I plugged in the wrong thing. Thanks, Justin. Copy that. Okay, so far forgetting it. -0.5. And we still get a negative though, thank goodness, 0.599. Okay, so is the function increasing or decreasing? Okay, h of x is decreasing at x equal to -0.5 because h prime of x is less than 0. Two points. Okay. Knowing that you needed to do the derivative at -0.5 and then your justification answer. All right. So we're up to 5. We got 4 more points to give. All right, then we jump to part C, and they just really start jumbling stuff together. says the region enclosed by the graphs is the base of a solid. Okay, the cross sections of the solid taken perpendicular to the x-axis are squares. Okay, so we've got our region, f of x minus g of x, and we're going to build a square. Okay. Right, so how do I find the area of a square?
You square.
I square the side. So the first side is f of x minus g of x, and all I'm going to do is square it. Okay, and so to get my volume, we're going to use that integral from negative 2 to b of f of x minus g of x, quantity squared, dx. Right, and again, we'll use our calculator to do that for us. Okay, so we weren't rotating it, we were just building something on top of it. So math 9, 0. B. Trace 1 minus trace 2, close the parentheses, square it, dx. I did something wrong. Oh, I put the wrong boundary in. I was like, wait a minute. Negative 2 to b, not 0. There we go. Okay. So this one was 2 points, one for the integrand and then one for the answer. Okay, so showing that you were just doing the square. Okay. All right, and then part D was where it got a little bit cray-cray. And it says a vertical line in the XY plane travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross-section above the vertical line with respect to time when the vertical line is at position x equals negative 0.5. Okay, now, what makes that so crazy is none of that makes sense to me. Okay, how can a vertical line and then have something move right and left with respect to time? There's just a lot happening right there, okay? But the one thing that does stick out to me is it's talking about the area, okay? Well, the area of that cross-section, I found that formula already, okay? So I'm going to start there. If I don't know anything else, it's talking about the area with respect to x is f of x minus g of x, the whole thing squared, okay? And so what we're going to do, because it seems like a related rate, we're taking things with respect to time, all right? We're taking things with respect to time. Okay, so let's just work on it. So the derivative of the area would be dA dx. Do we agree with that? And then times dx dt. So that would be the derivative of the area with respect to time. So we'd have to have both of those. Okay, so derivative of area with respect to x, and then dx dt. Okay. This is going to equal the same thing as the derivative of our area times dx dt. Okay, so those two things are equivalent, right? So the derivative of our area with respect to time would be the same thing as a prime evaluated at x times dx dt. And the reason I wrote it that way is on purpose, because if we look back in the thing, it tells me that the vertical line is moving at a constant rate. So that's that x equals 7 units per second. So that dx dt is the 7, okay? So it told me that. So we're going to make dx dt the 7. A prime is going to happen at 1.5, right? No, at negative 0.5. Why don't I want to say 0.5? All right, so at negative 0.5. That I can use my calculator to do. All right, so I'm going to take A prime at negative 0.5 and then multiply it by that constant rate of change. All right, so I'm going to do math 8, respect to x, y1 minus y2. At negative 0.5, get my answer, multiply it by 7. I did not get the right answer. A prime at negative 0.5. Oh, I didn't square it. There, I got it. Okay. So this would give me a negative 1.325 times 7, which would be negative 9.272. Right? Now, this was only worth 2 points. All right? So I'm not going to be real upset if we miss something like that. Okay? Because that's just that's worded really, really weird. All right? If you can figure out that you need to take the derivative of the area with respect to time, they gave you a point for recognizing that. Even if you didn't know how to carry it out, they did give you a point for recognizing it, which I think was great. All right, but most people did not get those last 2 points, just as a heads up. Okay? Across the world. All right, in 2022, we did not get those points. Okay, those last 2. We did pretty good with the others. Right, but we did not do well. I could go and look up and tell you exactly what our average was on that question, but we were above the global on that still, but yeah, we struggled with that last one. Okay. All right, and then I want to do this next one with you just because it has been in your packet, but we didn't get to it, and so I just added it back so that we could do this one together. And then I'm going to let you do a couple, and we'll kind of look at the solutions and see how we did, maybe put some stuff on. We'll just work, all right, and see how we're doing. So I just wanted to show you a few of these. All right, take a look at this one. This is one of those big, nasty tables. There's some fundamental theorem in here, just a little bit of everything, okay? Again, they start off by giving you some things where you can get some points maybe, and let's see what happens. So f and g are twice differentiable. That's important. It means it's also continuous. And so the table shown gives values of the functions and their first derivatives at selected values. Let h be the function defined by f of g of x, so it's a composition. And we want to find h prime at 7. Right. So if h of x is equal to f of g of x. Okay, how do we do derivative of a composition?
Outside derivative.
Yeah, derivative of the outside, we keep the inside, times derivative of the inside. Okay, so that's important. That's about knowing that composition formula. Okay, and now we're going to evaluate it at 7. We're just going to work it from the inside out. So we have f prime times g of 7 times g prime at 7. Okay, let's fill in what we know. Keep the f prime. G at 7 was 0. G prime at 7 was 8. Then we have to go back and look at f prime at 0, which was 3 over 2, which should give me 12. Okay. So even if you can't evaluate that correctly, if you did the derivative correctly, you got a point. Okay, so that's good. All right, if you struggled to put it in and get the right numerical values, it's okay. All right. All right. So now let's look at B. Okay. It says let K be the differentiable function so that K prime is equal to f of x, the whole thing squared, times g of x. Is the graph of K concave up or concave down at the point where x is equal to 4? Right? How could I know? Take a second derivative. Okay? This is the second derivative test, and that's exactly what they're testing right here. Okay? K double prime. All right? So this is going to be a chain rule, and it's going to be a product rule. All right? So it's going to be nasty. All right? So we're going to take the first function, which is f of x, the whole thing squared, times derivative of the second, plus second times derivative of the first. 2 times f of x times f prime of x. And they're kind to you on this one because if you do at least one time do the product rule or you at least do the chain rule, they'll give you that first point. So even if you mess up everything else, but you recognize you had to do product or chain rule, even if you're messy, all right, you would get the point. All right? And then we're going to evaluate it at 4. So worth 3 points. 1 for doing the product rule or the chain rule, 1 for getting K double prime, which was negative 40, and then 1 for your reason. Notice it put on there you had to have that K double prime is continuous. That is one of the requirements for the second derivative test, okay, is that it is continuous. And we knew it was continuous because it told me there was twice differentiable functions. Okay, K is a differentiable function. Okay. So again, I think most of those points are okay to get. We might make some arithmetic errors along the way, but the thinking on those is not as difficult as some of the others. Right? So it's possible to get part of those. Okay, so let's look at part C. So in part C, it says let m be the function defined by all that stuff, 0 to x f prime of t. Find m at 2, show the work that leads to your answer. Okay, so let's take a look at this one. So in part C, they tell me that m of x is equal to 5x cubed plus the integral from 0 to x of f prime ft dt. Okay, and we want to find m at 2. All right, well, we're going to start by just plugging in. So 5 times 2 to the third plus the integral from 0 to 2 of f prime of t dt. Okay. Now, to evaluate that antiderivative, 5 times 8, that would give me 40 at the front. Okay. What is the antiderivative of f prime? F. And we're going to evaluate it from 2 to 0, which means I've got 40 plus f of 2 minus f of 0, which I can pull from the table. Which would be 40 plus 7 minus 10, or 37. Okay. That one was only worth 1 point, but I think that's a point we could get. Okay. So at this point, we'll take every point. Okay. So literally just plugging in that 2 and going from there. All right, and then that last one is the function m increasing, decreasing, or neither at x equals 2. Right? What are we going to need to do to discover if it's increasing, decreasing? Take a derivative. Okay, so in part D, we're going to find m prime. So if m is equal to 5x cubed plus the integral from 0 to x of f prime at t dt, m prime going to equal 15x squared plus, this is fundamental theorem, if I take the derivative of that integral, okay, I would just plug x into the function, so f prime at x, okay. We're going to plug in 2, so m prime at 2 is going to be 15 times 4 plus f prime at 2. We're going to pull from the table. So 60 plus a negative 8, which will give me 52. Okay, so all of that work is worth 2 points. 1 for taking m prime and then 1 for finding m prime at 2. And then our justification statement, all right, the graph of m is increasing at x equals 2 because m prime at 2 is greater than 0. I'm going to do one more with you, then I will quit and let y'all practice a little bit. Okay? All right. So, this one is interesting for several reasons. Okay? It looks very similar to what we just did. Okay? Notice the table's written differently. Okay? This one is from 2007, so he's an oldie but a goodie. All right? So, it gives me that f and g are differentiable. G is strictly increasing, and that's probably important. I don't think they would have told me if it wasn't. Okay, I don't know when I'll need it, but I'm going to highlight that because that's probably important. The table above gives values of the functions and their first derivatives. The function h is given by f of g of x minus 6. Okay, so on A, explain why there must be a value r between 1 and 3 such that h of r equals negative 5. Okay? So let's think about that one. All right? Why there must be a value between 1 and 3 where h of r is equal to negative 5. Right? Any thoughts on how to proceed?
Would you get 3, like h of 3 and then h of 1? Okay.
Yep, we're thinking intermediate value theorem. Okay, we're thinking IVT on this one. All right, do my values. All right. Okay. So let's do that. Let's do h of 1. So that's going to be f of g of 1 minus 6. 2 f at 2 minus 6, which is 3. Okay, so we should get 3 and negative 7 when we do that. Okay. All right, so how do we prove it? How do we know it's true? Okay, so they told me that h was continuous. That's important. IVT, we have to have continuity. Since h of x is continuous, all right, and h of 3 okay, in other words, that value we're looking for is between what we found for h of 3 and h of 1. All right. There is a value r in the interval 1 to 3 such that h of r is equal to negative 5. Now, you could say by the intermediate value theorem, but you would also have to say it is continuous and that those values, that negative 5 is between those two values. You would have to say that, okay? So you don't have to say IVT, but you can, all right? If you look at solution guides, they will say by IVT, but unless they tell you to name the theorem, you do not have to, all right? You just have to meet the conditions, okay? Now let's look at B. On this one, all right, explain why there must be a C between 1 and 3 such that h prime at C is equal to negative 5. What are we thinking on that one?
The 2 slopes.
Yep, the two slopes. That's the mean value theorem, okay? So this time it has to be continuous and it has to be differentiable, okay? All right. So we need to find the slopes. Let's do that. We're going to need h at 3 minus h at 1 over 3 minus 1. All right, so the good news for us is we've already done that, the h of 3 and the h of 1, so I don't have to repeat that, okay? So I get negative 7 minus 3 over 2, which would be negative 10 over 2, which is negative 5. So because that slope, right, is equal to negative 5, then we can be, guaranteed by the mean value theorem that we have it, all right? So what are the conditions of the mean value theorem? All right, and it told me that. It told me f and g are differentiable, so that means their composition is also differentiable. So since h of x is continuous and differentiable, and h at 3 minus h of 1 over 3 minus 1 is equal to negative 5, all right, there exists a c-value. In the interval from 1 to 3, such that h prime at c is equal to negative 5. Those first two questions, all right, 4 points. All right, 4 points. You got one for the average rate of change and then one for your conclusion using the conditions of the mean value theorem. So that's nice. All right, I like this next part, all right, because it's fundamental theorem, but it's tricky fundamental theorem. Okay, tricky. Right? So on part C, it defines w of x as the integral from 1 to g of x of f of t dt, right? And it asks us to find w prime at 3. So we're going to take a derivative, right? Which in and of itself doesn't seem that terrible, right? If I take the derivative of the integral, we take whatever is on top and we plug it in for t, right? So I'm going to get f of g of x. Now the problem with this is g of x is a function, so I have to use chain rule, right? And what's the derivative of g? G prime. Right? So they're going to give you a point for knowing you needed the chain rule right there, right? And then we're just going to evaluate it when x is 3. So w prime at 3 would be f of g of 3 times g prime at 3. Right? So f of 4 times 2, which would be negative 2. Okay, and you got a point for the answer. Okay. All right, and then part D is where people would not get the points. All right. I don't know why it seems that sometimes the last part is the worst part, but part D we did not get many points on in 2007. All right, and this was before I figured out how to teach inverse so that I understood what was going on, because I was just faking it, I ain't gonna lie, in 2007. I had a 6-year-old. Okay. I was just trying to make life work at that point. Okay. It was really bad when she was a newborn. I felt so sorry for that first group of kids because I had a less than a year-old child and I didn't know what I was doing. Okay. All right. So it says if G inverse is the inverse of G. How lovely. Write an equation for the line tangent to the graph of y equals G inverse at x equals 2. Okay. So let's just think about that. All right, we want a line tangent to G inverse at x equals 2. Okay, at x equals 2. I want to make sure I do this right. Okay. So we've got our x and we've got G inverse. Okay, I've got my x and my G, right? Now, let's think about this for a second. If the x value on my inverse function is 2, what is it going to represent on my original function? The y. Okay? So we're going to go up here and we got to figure out where is g equal to 2? What x value? 1. Okay? So this is my ordered pair I'm going to use. I'm going to use the inverse ordered pair, which is 2, 1. Okay? But I'm also going to need the slope at g inverse. Okay? In order to get that, I'm going to have to use the slope of g at x equals 1, because what's true about those two slopes? They're reciprocals. Okay? So let's find the derivative or the slope of g at x equals 1. So g prime at 1 is 5. Okay? So g prime at 1 is 5, which means g inverse prime at 2, because I switched the x and y, is going to be 1/5. Okay, so you have the reciprocal on those slopes. All right? So then, using that point we found and our slope, we found the tangent line, y equals 1/5 x minus 2 plus 1. Okay? You get 3 points for that. All right? You get a point for getting the correct y value up here, the correct slope, and then the tangent equation. So it was worth 3 points, but we struggled with that. All right? We did. You really have to think about it to get it. Okay? All right. So what you have left, all right, are just more free response questions. Some that ask you to do a few different things, look at things a little bit differently. There's some rate in, rate out kind of things where you have to think about where would they break even and be the same. Overestimates, underestimates, using Riemann sums, candidates test. There's really good integration. There's just a lot of good stuff, okay? So I'm going to leave you all this. If you look on Google Classroom, I've posted the solution guides. All right, so I didn't just do them, I just did them for the ones that are on there. So you've got solutions guides to all of those. The only way to get good at free response questions is to do them. All right, and see what you can get points for. We don't leave here until 10:30, which is about 45 minutes from now. So you can play with these, you can take a nap. I didn't say that. Okay, but that's what we got to work on. Tomorrow, we'll only have an hour. And we're just going to do a Big 10, one that's calculator, one that's non-calculator, that covers everything. So it's got a lot of stuff on it, all right, in class just to practice through, and we'll kind of work through that together. And then Thursday, it's the final countdown. Yeah. You're ready. I believe in you. Okay. All right. I'm done. Good job. Thanks for listening to me and only being 5 of y'all. Appreciate you. The last time I only had 5 in a class.